And welcome to Otten Math. In this edition of Otten Math, we are going to do some practice problems involved in direct, inverse, and joint variation. We're going to get that all straightened out, and you guys will be ready to get straight A's on your quizzes and tests for this particular section. All right, so first set of practice problems. Tell whether x and y vary directly, inversely, or neither. So let's go ahead and review. Direct variation has the form y is equal to ax. All right. Inverse variation has the form y is equal to a over x. And then joint variation is a combination of these two. So let's see, in the first example I have y is equal to 2x. That to me looks like direct variation. My a value is 2. Y is y, x is x, and they vary directly as a factor of 2. Y is equal to 3 over x. That looks like inverse variation. My a value is 3. Okay, now things start to get a little trickier. Xy is equal to 9. Well, I can rewrite that as y is equal to 9 over x, right? 9, this is a 9. And it surprisingly looks like an A as well, and that gives us the hint that this would be inverse variation. Now, don't be mistaken. If I had joint variation, it would be z is equal to xy, right? But z is not, z is a variable. It's not a constant. This is our constant of variation. So in this case, this does not model joint variation, it just models inverse variation. So we rewrite it in terms of y. I have y is equal to 9 over x. That's inverse variation. And finally, y is equal to 3x plus 5. That's going to be neither. So remember, we had talked about this in the lesson, that with direct variation, the graph goes right through the origin, which means that there is no, in y is equal to mx plus b form, there's no y-intercept. So this graph that's drawn for number 4 would look something like this, right? And so it doesn't go through the origin. You can't have this constant if you have direct variation. So it's not going to be direct variation. It will not be inverse variation. All right, moving on to the next set of questions. The variables x and y vary inversely. Use the given values to write an equation relating x and y. So again, inverse variation, y is equal to a over x. We have to figure out what the a value is first and then write the equation. So now I have 2 is equal to a over 3. What I'm going to do is I'm going to multiply both sides by 3, and I get a is equal to 6. So I can rewrite my inverse variation equation as y is equal to 6 over x. It's that easy. So remember, students always get confused. They think that this is the answer, but it's not. This is not the inverse variation equation. It's just our setup to get the value of a, solve for a. Okay, same process here for number 6. I have 2 is equal to a over 4. I find out by multiplying both sides by 4, I get a is equal to 8. Now I can rewrite my inverse variation equation as y is equal to 8 over x. All right, last set of problems. The variable z varies jointly with x and y. Use the given values to write an equation relating to x, y, and z. So I know that when I have joint variation, the product of x and y equals z if z varies jointly with x and y. So z is equal to x times y. I need to find z when x is equal to 2 and y is equal to 5. Okay, so I'm going to find out what z is. I'm going to rewrite the equation. I have z is equal to 8. And then I have a, right? The a constant variation. I forgot to put that in. A times x, which is 2, times y, which is 1. I figure out that a is going to be equal to 4. So I have 2a is equal to 8. A must be equal to 4. So I rewrite my equation. Z is equal to 4xy. And this is my joint variation equation. And I solve when x is 2 and y is 5. So I have z is equal to 4 times 2 times 5. Z is equal to 40. All right, last problem, and we're all done, at least for this lesson. So I have a Z, the model, Z is equal to A x, y, when Z varies jointly with x and y. I'm going to figure out my A value. Z is going to be equal to 9. Is equal to A times x, which is 6, times y, which is 3. I have 9 is equal to 18A, and A is going to be equal to 1/2. All right, so let's erase the A value here and substitute it with the value that we just derived or determined. And I have Z is equal to 1/2 xy. Now I want to plug in the values x is equal to 2 and y is equal to 5. So I get Z is equal to 1/2 times 2 times 5. So Z is equal to 5. And that's my answer for number 8. Right, hopefully everything is clicking for you. If not, go back and review the lesson on inverse and joint variation, or you can go back as well and review problems on direct variation as well as a lesson on direct variation. I believe it's from chapter 3.